Okay, so welcome to the next lesson. So we are heading towards the linear regression. So basically a method for modeling the relationship between a dependent variable and one independent variable. If it involves one independent variable, it is known as simple linear regression. But if it involves multiple or more than one independent variables, then it is called multiple linear regression. So there is one dependent variable and one or more independent variables, and it models the relationship between them by fitting a linear equation to observe the data, to observed data. It determines the strength and character of the relationship between variables. It makes predictions and test hypotheses about the data. It is ideal for dose response studies mainly, and other analysis which involve continuous predictors. So yes, it analyzes the relationship between. Okay, so for example, we are analyzing the drug concentration. In this case, we have drug concentration and cell proliferation and percentage, and we want to observe the relationship between them. So this is the hypothetical data again, and we can use this to perform a linear regression analysis. So in this case, we have taken XY format of the table. And for XY format, we perform linear regression and non-linear regression. For t-test, for one-way ANOVA, we can repeat it. For t-test and one-way ANOVA, we have taken column format. Then for two-way ANOVA, we have taken grouped format. And then for linear regression, we are taking XY format. So for in X column, we have taken our drug concentration. And in Y, you can say, so we have one independent variable here. So this is cell proliferation in percentage. So we have 10 values here. And so we can go to analyze and we can perform linear regression here. So again, it will give us multiple options. You can change them, but we are going with the default ones for this time. So yes, it has given us this linear regression, some variables and their values. So what is important in this is, so basically, Graphpad Prism will generate results that include the slope, their intercept values, then we have R square values, and then P value. So these four values are important to study. So we check the R square value if it is it assess the goodness of fit for the model. So if an R square value is closer to 1, then it indicates a better fit. And then P value, again, you can say if it is less than obviously 0.005 or 0.001, then it is significant. And yes, we have significant data. And then we have a y-intercept and r-intercept, and then we have a slope value. So if the slope, so basically the slope represents the change in this data. It is representing the change in cell proliferation percentage for each unit increase in drug concentration. For example, if this is 3.386 or around 3, so it means that for every 1 micromolar increase in drug concentration, cell proliferation is increased by 3%. So let's say if it is 4 or 5, then the drug concentration for each 1 micromolar increase in drug concentration, the cell proliferation has increased by 4 or 5. So these are the main analysis in linear regression. So for graph, we have this simple line graph for linear regression models. So this is similar. Okay, so for graph linear regression data, we will go to new graph, and here, so first we have to select our data, which is data for linear regression. And from here, which kind of graph you want. So we have XY format table, and we have XY data for linear regression. So we will be going with this first one graph, and you can make all of these graphs for linear regression or for XY graph. So for our data, this is a little bit, you can say, skewed data. So yes, this is the first graph you can make, and then let's try another one. So make sure you have selected your right data from here and XY column, and let's see if we can make this graph. This is the standard or threshold line, you can say, and this is your dot points connecting line. And let's make another last one. This one, area fill graph. So yes, you can play around and you can make whichever graph you want, whichever graph you want to make for your your data. So yes, that's all about it. That was all about linear regression. So in next lesson we will be discussing non-linear regression.